Hey, so today I'm going to be discussing the mole. And so what is the mole? Well, the mole is just a unit of measurement, all right? So it's just a quantity, just like if you were to imagine you were going to go to the store and get some eggs, you might say, hey, could you grab me a dozen eggs? And you would say, you would know that when I go to the store, I'm supposed to get 12 eggs. Because you know that a dozen is a word that means 12, basically. All right, and you could do the same thing with the mole. The mole is very similar to saying a dozen. So if I had a mole of eggs, then that would just be 6.02 times 10 to the power of 23 eggs. And so that's a lot of eggs. If you had one mole of eggs, you would have 6.02 times 10 to the 23 eggs. And so let's just look at that number here. Let's look at how big that number is. So it's 602 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23 eggs. And so I could divide this up into thousands, so I split this up, and you would see that you would have 60 thousands of eggs. So you have a lot of eggs there. And so this is a huge number, and it's a very, very big number, and it's this guy, his name was Avogadro. He's the one that discovered it. And so this number is called Avogadro's number. All right, so Avogadro's number is that huge number, which is 6.02 times 10 to the 23 eggs. And so this number is just a convenient number. And so it doesn't have to be eggs. It could be anything. It doesn't have to be eggs. It might be atoms, for example. And that's what he discovered, is that there was 6.02 times 10 to the power of 23 atoms, and that's per mole, basically, okay? And so we drop the E when we're doing the unit, don't ask me why, and so we get 6.02 times 10 to the 23 atoms per 1 mole. And so this is just a convenient number, and it's basically the same number of atoms as in 12 grams of carbon. And so if we were to just basically grab a scale and measure out 12 grams of carbon, so let me just draw that out. So let's say we were to take a scale here, and we were to put some carbon on it. So let's go to black here, because that's what carbon looks like, that color. So we were to put, say, 12 grams of carbon on there, then what that scale would read is we would see that there's 12.01 grams, and that's what our scale would read. And so this would also be how many atoms are there. So in there, there's going to be 1 mole. And so when we have 1 mole in there, that means we're going to have 6.02 times 10 to the 23 atoms. So that's a huge number of atoms. So if you were to zoom in with a really crazy microscope and zoom in on that mole, you would see that there's 6.02 times 10 to the 23 atoms of that. And so that's just a huge number, but that's what a mole is. All right, so when we say we have 2 moles of carbon, then you know that would correspond to twice as much atoms, right? 2 moles would just be 2 multiplied by 6.02 times 10 to the power of 23 atoms. All right, so that's how many atoms 2 moles would have. So the mole is just a convenient way of measuring the number of atoms in a chemical or in a compound, basically.